Hello friends, this is lesson 11. So here we are going to talk about advanced probability. Under advanced probability, these are the topics: conditional probability, Bayes theorem, and then we are going to talk about the random variables, and we will provide some examples for them. Now let's start with the first topic. So before that, as we mentioned in previous lecture, there we said probability is nothing but it is a branch of mathematics. It is used for modeling the events that may or may not occur. So that is why we need the probability to understand, and we are using them in modeling or data science. So it is required. It is a prerequisite also. So now let's see here the conditional probability. What is conditional probability? The name itself indicates conditional probability means the probability of an event given that another event has already happened. So if this is the case, that is called conditional probability. Two events, but one event has already occurred or happened. So this is called conditional probability of A given B. A given B, and here it is represented by this probability of A given B, or you can pronounce it like this: conditional probability of A given B, or here you can write it like probability of A given B. So probability of B, for example, given A or A given B, here it is B given A, so it is equal to probability of A intersects B divided by probability of A. So it can be represented like this: probability of B given A is equal to their intersection divided by probability of the given probability. Okay, for example, here two coins are tossed. What is the conditional probability of getting two hits given that? So see here, given that at least one coin is showing hit. Okay, so here let A be the event of getting one coin shows at least one hit. So A represents the event of getting one coin shows at least one hit, and B is the event that is used to show two hits. So if a coin is tossed two times, so what is the sample space for that? So this is a sample space. Either we will be getting two heads, one head, one tail, or one tail, one head, or both the tails. So if we go to here, the condition A represents what? The coin at least shows one head. So at least, so this is head, here also we have head, and here we have two heads. So the condition is at least one head. So this is the event A. So let's see event B. Event B says B be the event of two hits. So we have only one event for getting two hits. So now what is the probability of A? So the probability of A, so this is sample space. How many outcomes are there? 4 outcomes, or total number of outcomes we have 4, and 3 we have in event A. So 3 by total number of outcomes, so that is 3 by 4. What is the intersection? Intersection of A and B. What is common between these two? We have only one, that is double hits. So 1 divided by 4. If we put it in this formula, probability of B given A is equal to their intersection divided by this. So intersection is 1 by 4 divided by 3 by 4, and that is equal to 1 by 3. And now let's see about Bayes theorem. And Bayes theorem, it says in the probability and statistics, Bayes theorem describes the probability of an event. Here also it shows the probability of an event, but here it is based on prior knowledge of conditions. It means this Bayes theorem is based on conditional probability and based on prior knowledge. It means based on past knowledge we predict the future that might be related to the event. So Bayes theorem is a way to figure out conditional probability. Okay, here we have from multiplication rule, as you said before. So here we have, okay, their intersection or multiplication rule, if you remember. So P of A intersects B is equal to P of A and B, and that is equal to P of A, okay, into P of B given A. So from this we can get that P of A comma B is equal to this one, the same, this one, and P of B comma A, we change, we swap these two events. So again we have probability of B into probability of A into B. Because these two are equal, we can change the, swap them. So after that, instead of these two, we can put their values here. So this is probability of A into probability of B given A into this side probability of B into probability of A given. Now if we divide both the sides by probability of A, what we are getting, probability of B given A is equal to, because this will be cancelled with this one, so only this part will remain on the left. So on the right, what we have probability of B into probability of A given B divided by probability of A. So this is called the Bayes theorem or Bayes formula. So here some basic terminologies that you need to understand. First, probability of B, and that is called prior knowledge, the probability of B being true, this is the knowledge actually. Then we have likelihood, we have probability of A given B, probability of B A being true given B, we can say. Then we have posterior probability, and that is probability of B given A, the probability of B is true, then A is also true. Okay, normalization constant, we have this one, what we divide on, so probability of A, the probability of A being true. Okay, let's talk about random variable. So what is random variable? So random variable, it is nothing but a numerical variable whose value is determined by outcome of the random experiment. So we have random variable and we have variable. Variable can take any value, friends, but random variable cannot take any value. It is taking only the values which are included in the domain or in the range. So out of the range it cannot take the value, but within the range it can take any value. So that is called random variable. So what is the range here? For example, if we consider the example of throwing a die, so this is the sample space and these are the outcomes. 6 outcomes we have, total number of outcomes we have 6. So a random variable, so here we can have a variable that can take either 6, 5, 4, 3, this one or this one, but it cannot take 7 because it is not a normal variable, it is random variable, and that is created for this die, throwing the die. For every value that the random variable might take on, there is a single probability that the variable will be this value. So it can be shown like this: f of event is equal to its probability. Each and every of these events has a probability. What is the probability of 1? 1 by 6. Probability of this one is also 1 by 6. Probability of this one is also 1 by 6. Each of them has one probability. So again, this one, random variable, will be divided into two parts. We have discrete random variable and we have continuous random variable. So what is discrete random variable? And discrete random variable, x is said to be discrete if its range is countable. Range is countable. It may be finite or infinite. For example, here sample space is equal to 1, 2, 3, 4, 6. So whole number, it is not in fraction form, it is whole number. So for example, 1, whole number 1, 2, and we have this one 3, 4, whole number. So x is our random, discrete random variable, and that is equal to this one 1, 2, 3, like that 6. So this is called finite, because we know that how many values are there, but here we cannot say what is the last value. So 1 to the power of 2, 2 to the power of 2, 3 to the power of 2, 4 to the power of 2, it is going like that. So this is called infinite. This is called infinite. So here the probability mass function, you have to know, friends, that is called PMF, probability mass function. What is that? Used to describe discrete random variable, like this. Probability of discrete random variable is equal to a value, and this is called PMF. For example, okay, consider the random experiment of tossing a coin. So PMF of that is equal to, here x is a random variable, is equal to 1. So its probability is equal to 1 by 6. Or for example, another one, P of x is equal to 5. So what is the probability of 5 in this range? So the probability of 5 in that range is 1 by 6. And then the last one we have here, continuous random variable. So continuous random variable means a random variable, okay, if range is uncountable. So they are not whole numbers, they can be in the form of fraction as well. For example, the height, the weight, amount of sugar in an orange, like that, they are called, okay, continuous random variable. So now let's see here some examples. So first we need to some libraries that I have imported here. Then we talked about conditional probability, and the probability of an event given another event has already happened. So this is the formula, probability of B given A is equal to their intersection divided by. So this is conditional probability. Let's have an example here. Suppose 70% of cars have air conditioners and 40% of them have CD player, and 20% have both. Both means they have CD player as well as air conditioner. So now the question is, what is the probability that a car has CD player given that has air conditioner as well? So for that, probability of A is equal to 70%, so 0.7. Probability of B is equal to 40%, and that is 0.4. So their intersection is, here is the intersection, which means it has both CD player and also air conditioner. So what is that? 20%, and 20% of that is 0.2. This is the formula. You put it according to this one, their intersection divided by probability of the given event. So intersection is 0.2 and given event was 70%. So if we are calculating this, the result what we are getting, so this is 29% is that a car will have both air conditioner and also a CD player. Okay, now let's see another example, friends. Here, find the probability of passengers survived on the Titanic ship, and also specify the probability of female and male. So that is very simple. We are, okay, I'm taking the data set, this data set you are familiar with. I'm reading the data from that, and I'm taking only two columns, 6 and survived, because we need them. It is as here, survived passengers and also probability of male and female. So we are executing this part. So male and female here listed, and survive and dead here is shown by 0 and 1. 1 means alive and 0 means dead. Dead, alive, dead, alive. Female and male are the people here. Okay, now let's first, I'm we have to, if you are finding the probability of male or female or whatever, we have to know the total number of observations. That is important for us, because we are dividing the favorable outcomes divided by total number of observations. That is a formula, or classical probability, that was the formula for that. So total number of rows, if you want to count, so okay, this one tectonic, this is our data set, data frame. So shape means you take the first column, not the second column, so that will be the number of rows here. 891 is the number of rows. If you remember, friends, like this, if I put here, so how many rows we have? We have this much rows. In 2 columns we have male and female, but I don't want this one, so this is 0 and this is 1. That is why I said you from the shape you take 0 location and store it in this variable. So total we have 891 observations. Now here, first find the probability of people survived. So this is the formula, friends. Total favorable number of outcome of E divided by total number of outcome. So that shows the probability of that event. So survived, if you want to find the probability of survived, so we say tectonic survived is equal to 1, because 1 indicates the people survived here, and 0 indicates they were dead. So here, okay, survived is equal to 1, and you take that value and put it in this variable. And for male, again we have to put a condition here. We are filtering only male data, because 6 is equal to male, and that is stored in this one. Now if you want to find the probability of survived, so P of survived variable is equal to probability that survived divided by total number of rows. So total number of rows was equal to 891, friends, here. And male, here if you want to find the probability of that divided by total number of rows, so that is called P male probability, and here we have P survived probability of survived. And now if you want to print them here, so P survived is here. What about the people who died? So for them, I am not using the probability, I am using its complement. If you remember the complement, 1 minus probability of event. So for male also I found here the probability of male, but if I go to female, I don't need, otherwise you have to change here 6 to female, that is also possible, but I am taking the complement of that. If the complement of female male I take, so it is giving me female. So these are the percentages. Here we have people survived is 3.8. Okay, we can say that 38%. Here it is 62% people died, and here we have male how much? Okay, we have 65% male and 35% female we had. But in conditional, this was not conditional, it is just like normal probability of events we found, but here we are going for conditional probability. In conditional probability, it says what is the chance that someone survived given that they were female. So here is the formula, friends. P of female survived divided by P of, according to this their intersection, this is the formula, intersection divided by probability of given event. So how to find this? First I have to go and find the female who were survived. So for that I say female survived. I created a variable which is equal to, okay, you take female at the same way and is there, and from the tectonic you take those who are survived. Survived means it is equal to 1. If I put 0 means died. So now we found all female who were survived. So this is the variable and it is stored in that. So what is the probability of that? Probability of that total number female survived divided by total number of rows. So total number of rows, you know that it is 891. At the same time, we have to go and find this one, female. So for that I say, okay, you take all the values from the data set who are female. So female data is filtered, it is here. Now we want to find the probability of that. Female divided by number of rows. Now we found the probability of female survived and the probability of female. You divide that. Probability of female survived divided by probability of female, and that is giving us the percentage. Probability given survived female is equal to how much? 74%. Then we have Bayes theorem. In Bayes theorem, this is the formula, friends. It is based on conditional probability. As we said here, probability of H hypothesis given data is equal to probability of data given hypothesis into probability of hypothesis divided by data. So we talked about some terminologies. If you remember, we have prior, PH is called prior, and this one is called likelihood, and this one is called posterior, and we have normalization constant. Friends, but it is not stopping. This is the general form. This is called the general form. But this PD further can be divided or splitted into mutual exclusive events. It is not only this one, it can be further splitted. Further splitted means like that. See, it can be splitted into two mutual exclusive events like D in H and D and not of H, and that can be represented by this formula symbol. We can write it like this: not of H or not of H, you can say. So it is converted into this form: P of probability of D given H, probability of H, according to this, probability of D given H, probability of H divided by probability of D, but D is splitted into this one. And now the formula is changed: probability of D given H, probability of H plus probability of D given not of H and probability of not of H. So now let's see and have an example for that. So here the probability that a high school student being male is how much? 1/3. Probability that the high school student being male is 1/3, being female is 2/3. The probability that the male student completes the course successfully is how much? It is given 7/10, and probability of female completes the course is here 4/5. Now if a student selected randomly found the probability is either male or female. Now among them, if we select a student who has completed the course, we select them randomly, you show whether it is male or female. So according to that, now let's see, D represents the event of student completed the course, H1 represents selected student is male, and H2 selected student is female. Now according to the values, you put the values here. Probability of student being male is 1/3. Probability of student being female is 2/3. Probability of student male completed the course is how much? 7/10, and probability of female completed the course is this one. Now according to this formula, if you put it here, we are getting probability is here completed the course, and that is male, divided by probability of completed course by male plus completed by female into this one, probability of them. So it is showing me probability of student being male and probability of student being female, and this is a percentage. So male is 30% and female is 69%. Now then we talked about random variables, friends. So what is random variable? We said random variable, it is a numeric value whose value is determined by outcome of the random experiment. So then it is divided into two types. We said we have discrete random variable and we have continuous random variable. In discrete random variables, we give the example of dice. For example, in dice we have whole numbers like 1, 2, 3, 4, 5. It is not accepting like fraction part as well, so whole numbers. So random variable x is said to be discrete, okay, if its range is countable. It may be finite or infinite. Now let's see here. This is an example, rolling a dice, and this is the function, friends. If you remember, you studied this. The range is given here 1 to 7, because 1, 2, 3, 4, 5, 6 values we need, and that is the range given here. And now let's see, and throwing the die, what we are getting. For first time I'm getting 6, again second time we are getting 4. Anytime you are running, you are getting different values, but whole numbers. These are called whole numbers. These are called discrete values. If I'm showing them in the form of graph, let's see, friends, see. Okay, 1, 2, 3, 4, 5 and 6 is the highest number there. So they are whole numbers. It is not taking the numbers in between. For example, between 1 and 2, there are so many numbers like 1.0 point something, 1.0 something, 1.2, 1.3, 1.4. They are not taking those values, only whole numbers. So this is called discrete numbers. Let's let's roll 100 dice and average the result. So this is the function we have already created. I've created a variable here 100, and through that 100 we are calling the same function, and see the result here. This is the result, 3.9, but it should be like 3.5. It is not exact, but it should be some, probably it is near to that. It should be 3.5, because the average of those values from 1 to 6, if we take, so the average is the probability of average, that is called, so that is 3.5. Now that is called the expected value. The average value is called, in random variables, the average value is called the expected value. So the average or mean of discrete random variable over a large number of experiments, so that is called expected value. So expected value is equal to expected of random variable. X is equal to mu into x is equal to summation of x into its probability. So for example, the event of 1, so what is the event of 1? What is its probability? The event of 1 probability is 1 by 6. In 2 also 1 by 6. 3 is also 1 by 6. If we are adding and multiplying these numbers, so the result will be 3.5. That is called expected value, and we can calculate it here. See, very simple. I created a function here, expected value, x is equal to 0, and I say, okay, you go from 1 to 7. It is not taking 7, it is going up to 6. So divide each number every time by 6, because each number, it becomes 1 divided by 6, 2 divided by 6, 3 divided by 6 in total, and you add them all, and the result will be stored in x, and then return that. And here I am printing the function, and now let's see, the result is the same, 3.5. And the next thing which is important here, it is under properties of random variable. First we talked about expected value, and then we have variance. So what is variance? Variance indicates how much the numbers are spread out from each other. So the variance of random variable represents the spread of the variable. So it quantifies the variability of the expected value. So this is the formula. Variance of x random variable is equal to expected value of square of those numbers minus expected value whole square. So for that, I've written a function for calculating the same function, but here I have to first find this part. I have to square each number and then divide it by its probability. So square the number, divided by 6, square the number, divided by 6, square the number, divided by 6. So here the same, first you square this, then divided by 6, then here square this because we need this, square each number and then divided by its probability, and that is expected value. So return that. So it is returning that variance value here minus expected value whole square. So expected value, I have already written a function here, I am just calling this function. This is finding the expected value, but here I have to square it, whole square, and that is giving me the result, and the result is 2.92. So that is called the variance. And now continuous value, friends. In continuous random variable, a random variable is called continuous and if its range is uncountable. So here we have x is a continuous random variable and there is a function for that fx for a constant a in b. So a in b is called nothing but the bounds, upper bound. In lower bound we have the limit, upper bound, because we have to specify the range, and within that range it can take any number, it may be fraction part as well. So this is lower bound and this is upper bound, and this is fx the function. So this fx function is also called the probability density function, PDF, and that PDF is the same as PMFM in discrete numbers, if you remember. So fx is equal to 1 by, this is the formula, friends, for continuous values. And if you remember, for random variables, for creating, we had a function random, but this random number, it is creating random numbers between 0 and 1. If you remember, 0 and 1, it is creating any value between them. For example, if I run, so this is a value. Second time if I'm running, it is giving me something different, but it is not exceeding the range. The range is 0 to 1. So this is random. If you are changing, so instead of this random, you can take the random int like that, but it is creating these numbers for us. But let's I want to execute this function here. Now for executing the function, that is called normal PDF of that. So we have x and we have mu, which is equal to 0, sigma is equal to 1. And this is the formula 1 divided by square root of 2 into pi, 2 into pi into sigma square. So sigma square into, so the whole formula is written in the form of a statement here. Now it is returning the value, and from here I am passing the values to that. This is x value, and I say you specify the range here from -5 to 5. You divide those numbers into 100 pieces. From -5 to 5, the values, how many values you want in between? 100 values I want in between. So that value I am passing to this x from here. So y value is equal to, I am calling the function and passing the x, and this is the if you remember this, you studied. So the for loop I have created within the loop list, that is called list comprehension, if you remember. So there I am calling every time for that x value, I am sending a single value to this function, and I am printing and plotting it here. So here this is the 0, and here is the range from -5 to +5, but it is not showing it here, but -4 and +4 it is showing. So this is called the 0, this is called the mu, or this is called the mean of the distribution. And here this is -2 +2, this is called the standard deviation, we can say. And here see, it is taking each and every value in between. It is not like that. See, here also we had like this. It is not taking only whole number, but the numbers in between also it is taking. Like it is starting from -5 point something, -5, another value, it is taking whole numbers up to +5. So the whole range is taken. But here you can change here the mu value, This is the mean from 0, for example, to 1. If you change it, so see, it is here, 1 is here, and it is distributed around that. If you change it to 2 or -2, for example, so it goes to that side, it comes to this side. And also, if you want to check the spread out, how much it is spread out, so that is nothing but the standard deviation. It is 1, I want to say 2. So that is showing me in this form. I hope you understood this much, friends. We talked about random variables, conditional statements, and also Bayes theorem. I hope you understood this much.